Okay, in this example, we're going to solve the equation 2 cosine t equals -1. The first step is to isolate the trig function involved in the equation, which is cosine t, so we can divide both sides by 2 to obtain cosine t equals -1/2. Now, -1/2 is a familiar cosine value, so we should be able to figure out what t needs to be. To help us out, we could consult a unit circle. We know that cosine represents x coordinates on the unit circle. So the number -1/2 must be here on the x coordinate, axis. And what we need to do is find a point on the circle that has an x coordinate of -1/2. So we could come up to the circle, figure out what this point needs to be here. If we draw the terminal line of the angle that will specify that point, then we can go ahead and draw the angle in here. And we should be familiar with the fact that the angle 2 pi over 3 has specifies an x coordinate of -1/2 on the unit circle. So 2 pi over 3 should solve this equation. So that means that t could equal 2 pi over 3. Now, since this cosine function has a period of 2 pi units, we know that if we add 2 pi to this solution, we'll get yet another solution to the equation. But not only can we just add 2 pi, but we can add any integer multiple of 2 pi to obtain an additional solution. So what we can do is we can sneak a little k in here to call it 2k pi and define k to be any whole number or any integer, which is what the set z represents. So now we've represented infinitely many solutions to this equation, all of the angles that are coterminal with this angle 2 pi over 3. But that's not the only place on the circumference of the unit circle that we get an x coordinate of -1/2. Another place is down here in the third quadrant. This point here also has an x coordinate of -1/2. Now we could pretty easily, think through what that angle needs to be, what the angle is that would specify that point on the circle. But another option is just to utilize the identity cosine t equals cosine of -t. It turns out that any angle t has the same cosine value as the opposite of that angle, -t. So since we've discovered that 2 pi over 3 is a solution to this equation, another solution must be the opposite of 2 pi over 3. And then if we come over to our circle and just kind of verify that, we can see that -2 pi over 3 would in fact be that angle. And then we can do the same thing we did with our first solution. We can add 2k pi to represent all of the angles coterminal to -2 pi over 3 and define k as a whole number.